Crash Course Instrumentation, Episode 37 Full Power, Joule's Law and Why Resistors Burn Up. In this episode, we turn up the heat, literally. We're diving into Joule's Law, the equation that explains how electrical energy becomes heat in a circuit. Whether you're sizing resistors or troubleshooting hot terminals, this one's essential. What is Joule's Law? Joule's Law tells us that power equals voltage, x current, or P equals Vxi. This describes the rate at which energy is consumed or transformed in a circuit. In resistive components, that energy becomes heat. Alternate forms of the equation. Ohm's law gives us two more ways to express power. P is I²R, great for current-driven circuits. P is V2-R, useful when you know voltage and resistance. These forms show us that even small increases in voltage or current can result in exponential heat generation. For example, doubling the current quadruples the heat output. Why resistors burn up? Let's say a resistor is rated for 0.25 watts, and you push 0.5 watts through it. It might heat up, smell bad, change color, or crack, eventually fail completely. This isn't just annoying. It can throw off your entire measurement loop, create false readings, or even become a fire hazard. Real-world example. Suppose you're working on a 24-volt DC loop and have a 1,000 ohm AU resistor. P equals V2, R equals 242, 1,000 equals 0.576 watts. That's more than double what a typical 1/4 watt resistor can handle. You'll need to upgrade to a half watt or 1 watt resistor. Technician tip: when in doubt, go higher on the power rating. Oversizing resistors is cheap insurance against heat-related failure. Don't forget the Uglies book. The Uglies Electrical Reference is a go-to guide in the industry. It includes quick charts and safe load tables for power ratings, wire ampacity, voltage drop, and resistor sizing. Keep one in your tool bag, you won't regret it. The history of Joule's discovery. James Prescott Joule was a 19th century physicist who helped prove that energy isn't just used, it's converted. He showed that mechanical, thermal, and electrical energy were interchangeable. In one famous experiment, he used a falling weight to stir water and measured the resulting temperature rise, proving that mechanical work could generate heat. This discovery became a key building block for thermodynamics, leading to the principle of energy conservation. That's why the SI unit of energy is named the Joule, J in his honor, where Joule's law shows up in industry. In power resistors for breaking energy in VFDs, variable frequency drive. In heater elements and thermal sensors, in fuse design and overcurrent protection, in estimating load ratings for analog signal conditioning loops. Technician takeaway: always check power ratings on resistors. Use P equals I²R when troubleshooting heating issues. Remember, too much current equals too much heat equals failure. Know when to upsize and when to question your loop design. Next time, we'll explore how to use Ohm's and Joule's laws together to model real-world loads and design better control systems. Like, share, and subscribe to keep the power flowing with Crash Course Instrumentation.